In 8th grade, section 810, we're dealing with systems of equations. So in this case, we're dealing with not just one equation, but multiple equations. I think with this section, we're just sticking with two. But any systems of equations is basically two or more equations that share common answers. So what that means is if I have an equation and I have an equation, there's going to be a part where they intersect. That intersection means that that point is true for both equations. So in order to solve a system of equations, I have to find that common point. And if the lines are parallel and they never touch, then there is no answer. So, but in this case, if I'm dealing with two lines and I graph them, then wherever they intersect is called the solution to the system of equations, because these two would become a system. Instead of just one equation, I'm dealing with two. All right, so let's start to see if it makes a little sense. So basically, I can solve this by two methods. I can solve it graphing. I can solve it by substitution. You need to understand both. The graphing will let you see a little bit of how the systems of relations are working, and then I'll show you a mathematical way where you don't have to graph it. So if I want to graph, remember my B is my starting point. And then this is where I move. And because there's no number in front of that x, just a negative, I'm assuming it's a -1. And I need my slope in fractions, so it would be -1 over 1. And this is my movement. Right? So that means I'm going to start at 5. 1, 2, 3, 4, 5. And then I'm going to go down 1, positive 1. Down 1, positive 1. Down 1, positive 1. Down 1, positive 1. Okay? And this is my first one. Okay? My second one starts here. So I'm going to start at positive 2. And I'm going to go, because it's a whole number, I'm going to put into fractions, so over 1. So I'm just going to go over 2, up 1. Over 2, up 1, over 2, up, and I can go backwards by doing the backwards. If I went up 2, then I'm going to go down 2. If I went right 1, I'm going to go left 1. So down 2, left 1. See, it continues the trend if I want to go backwards. So I'm going to connect this right here. Okay? So these are these two graphs. This is this one, and this is this one. Okay? Now they're just two, it's nothing new. It's you graphing two lines in one. It's just wherever the 2 points share right here, that is what we call a solution. That is where they overlap and they share the same point. So this is 1, comma, 1, 2, 3, 4. So 1, comma, 4. Now, this is very important because on a graphing paper is when you can get it more exact. So hopefully that's the right one. So this should be my solution. Okay? Now this was easy to graph because it's in a graphing kind of, because it's in y equals mx plus b. But it's not always going to be this simple, and they're not always going to have a straightforward starting point and movement. So sometimes you need to go substitution, sometimes graphing is easier, but you should be able to use both to solve. So I'm going to use the substitution method. And basically, what the substitution method is, I can take, because I need to know when x and y are the same. That means if I plug in 1 for x, it's going to give me 4. And if I plug in 1 for x here, it's going to give me 4. So these both should share the same x and the same y. So if I have an equation y equals negative x plus 5, and I have y equals 2x plus 2, because these both equal x, just like if I said x equals 1 here, that means I can plug in 1. They're interchangeable. You can substitute them. And so it's the same concept here. I can't solve this equation alone because it has an x and a y, and it has two missing variables. And we discussed it in class that you can only have a maximum of one variable. So what I'm going to do is I'm going to take this y away. Okay, and I'm going to take this entire equation, because y equals the entire equation, and do 2x plus 2. Because in both equations, y should be the same. So I'm going to replace it. I'm going to substitute it, hence the substitution. When I do that, now I only have one variable, and that's x, okay? So what I'm going to do is I'm going to isolate, so that means I'm going to bring everything over and just isolate one of the letters, it could be y or x, and then I'm going to replace it with the other one. So I can erase this, and now I can solve. Right? So substitution is just basically isolating one letter. So this one just so happens to isolate. So for example, if this one was written y equals negative x, y plus x equals 5, then I subtract x from both sides and I end up with y equals negative x plus 5. And then I can substitute it. So I have to first, however way they give me, I need to isolate y before I substitute, or isolate x. It doesn't matter which letter. But once I substitute, then I only have one letter. And now I can solve mathematically. So from here, it's just algebra, so I'm going to subtract 2 on both sides. I end up with this canceling out, and 2x equals negative x plus 5 minus 2 is 3. I'm going to add 1x. So 3x equals 3. Divide by 3 on both sides. This cancels out, end up with x equals 1. Okay? But this doesn't give me that. It just gives me the first one. So once I find one of them, then I'm going to plug it in. But because it should be true for both, it doesn't matter. I can plug in 1 from here, and it should give me the same answer as if I plugged in 1. So once I find it, I'm going to plug it in. Let's plug it into the first equation. Y equals negative 1 plus 5. Y equals 4. If I plug it into the second equation, y equals 2 times 1 plus 2, which is y equals 4. Okay, I'm going to rewrite this. You can start writing this down, but this is the messiest ever. So this one I'm going to plug in to y equals negative x plus 5. This gives me y equals negative 1 plus 5, which gives me y equals 4. Or I can plug it into y equals 2x plus 2, which is y equals 2 times 1 plus 2, which is y equals 4. It doesn't matter which way I do it, it's going to be y equals 4. So in this sense, my x is 1 and my y is 4, so my answer is x comma y, which is 1 comma 4, which is the same answer as up here. Right? So it doesn't matter which way I solve it, I'm finding this point where both lines intersect. So go ahead and try page 463, numbers 2 and 7, 463, numbers 2 and 7, and hopefully that makes sense, and I'll see you in class.